Good morning, good morning, good morning. Okay, so make sure before you even watch this lesson that you go and open up day one notes. If you can print it out, do it. Day one worksheet is what will be on the video where you just see my hand, the key. And today we are talking about exponential functions, right? So it's kind of like a linear function and also kind of like a parabola. These things aren't going to go both one direction, right? They're not going to be a U-shaped. They're going to be this line that goes on and on forever one way and up forever another way. So this is kind of how you want your money to grow and not coronavirus cases to grow and stuff like that. Okay. So exponential growth is what we're talking about today. What is the standard form? By the way, go open up the notes. I'd rather you listen to this and look at the notes than look at this and not look at the notes, okay? So the standard form for exponential functions is going to be y equals a times b in parentheses to the power of x plus c. That power of x, the power that keeps on changing over the time. That's what we're looking for with exponential functions. There's also another word you need to know called asymptote. Asymptote is Asymptote is a line that the graph approaches but never touches, okay? It approaches but never touches. So if we look at the previous drawing that I had here, it's something simple like this. This line right here, when it's coming down, it's going to flatten out. And it's going to get very, very, very close to a number but never touch it, okay? That's the asymptote. So like if it got very, very close to 0, right? If this was on if this was on an axis or a coordinate plane, it got very close to the number 0 but never touched it, right? That's what we're talking about. It would get so close that we might as well call it 0, but it's not ever going to be that number, okay? Now, that's what an asymptote is. We can have a horizontal asymptote. We can also have vertical asymptotes. We can have lines that the graph will never touch, but it gets really, 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 really close to it. Think about it this way. And if you want to do this thought experiment, go ahead and listen to it and then hit pause. Stand on one side of the room and walk halfway to the door. So right now, if you're in your bedroom, stand on one side of the room and walk halfway to the door. And then walk halfway again. And then walk halfway again. And walk halfway again. And halfway again, and again, and again, and again, and again. Are you ever going to get to the door? No, because you're always a little bit away from the door, okay? Even if it's microscopically, you're always a little bit away from the door because you're only going halfway, right? So you're never going to exit the door or touch the door, but you'll get really, really, really close to it. That's what an asymptote is. Okay. Another thing you need to know is there's exponential growth, but there's also exponential decay. Okay. So whenever we talk about money, hopefully it's exponential growth. But if we start talking about like population, cities that are, like coal mining cities, things where the jobs are kind of, disappeared, things like that, that experiences exponential decay. Okay. We have two scenarios. We have one when X, you remember X is mostly time, usually time. So when time is increasing, so when time passes by, the population either increases or the population decreases, okay? So when X increases and Y also increases, that's called exponential growth. And when X increases and Y decreases, that's called exponential decay, okay? Those are the two scenarios we're going to be talking about. Exponential growth and exponential decay. And notice my arm curves whenever I'm talking about this because it's never a straight linear path. We don't grow at a set rate every single day. We don't decrease at a set rate every single day. It decreases exponentially. So 1 turns into 2, 2 turns into 4, 4 turns into 8, on and on and on and on and on. Okay? All right, so those are the main terms you need to know today. We have our standard form. We have a definition of an asymptote. And we have exponential growth and exponential decay. Remember, this is just saying when time moves on, when time increases as the day goes on, y either increases or decreases. Okay? So let's look at number 1. We're going to do 1, 2, and 3 on the practice on the notes here. Number 1 says that we're going to graph f of x is equal to 3 to the power of x. And that power of x is where we get our change. So what we're going to look at is we're going to say that, let's see, we have a graph right here. When x is what, when x is 1 or 2 or 0 or whatever, what is y? So I like to make, that I like to make graphs, or I like to make tables when x is -2, -1, 0, 1, and 2. I like to make those types of graphs. So 3 to the power of -2, if you want to type that in your calculator, please do so. 3 to the power of -1, 3 to the power of 0, everyone should know that. 3 to the power of 0, anything to the power of 0 is 1. 3 to the power of 1 is 3, and 3 to the power of 2 is 9. 3 to the power of -1 is actually 1/3, and 3 to the power of -2 is actually 1/9. So you remember whenever we had negative powers, we just flip it, right? So, or shift, we push down or move down. That's all that's happening here. We had 3 to the power of 1, which is 3. -1 would be 1/3. 2 is 9. -2 is 1/9. So let's graph that real quick. When x is -2, we have y is 1/9. So just a tiniest of tiny dots, somewhere about 1/9 up that value. When x is -2, y is 1/3. So somewhere 1/3 up the axis right there. And then when x is 0 along the y-axis, we finally have a value of 1. When x is 1, we have a value of 3. And when x is 2, we have a value of 9. 3, 6, 9. See how it's taking off like a rocket ship all the way up there? So whenever we graph it, we're getting really close to this line. And then, all right. That's what's going on here. We have exponential growth. When x is increasing, y is also increasing. As x moves toward the positive area, our y value is increasing, and once it gets to the positive area, it really increases quickly. Okay, so that's what our graph is going to look like. Now, what is our x-intercept? Well, it never touches the x-axis. There is not an x-intercept. All right. It gets really, really close to the x-axis. In fact, you can type it in your calculator, 3 to the power of -10 or 3 to the power. It's always going to be 1 over something. It's always going to be a fraction of 1 over something crazy. Okay, it'll get really, really small, 3 to the power of -50, and you think it'll be 0, but it'll just get really, 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 really tiny. So our x-intercept, there isn't one. Our y-intercept crosses right here at 1. And then our asymptote is what it approaches, but it never touches. And that is when y is equal to 0 on our x-axis. It approaches our x-axis, but it never touches our x-axis. Okay? I hope you understand that portion of it. I'm going to hit pause real quick, and then I'm going to move on to the next one. All right, so if you're looking at number 2, it says that our equation is 2 to the power of x plus 4. If we look at that equation, 2 to the power of x plus 4, notice where x is again. That's what makes it exponential growth. If we create our own table, you can type this into y equals and create your own table that way. It's really, really fast. Type this in, make sure that you move your right, or once you hit to the power of x, make sure you move the arrow to the right again, so it'll bring you back down to the bottom, and you can hit plus 4. All right. So when we do that, we can move over to look at our table. I like to use -2, -1, 0, 1, and 2. That's kind of the meat and potatoes of the graph right here. So when x is -2, y is 4.25. When x is -1, y is 4.5. When x is 0, y is 5. When x is 1, y is 6. When x is 2, y is 8. And then it moves up from there, 12, and on and on and on and on. Right? So what this is doing is, in this equation, whenever we're changing our x's, we're changing this exponent right here. So it would be 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 3, 4, on and on and on. And then after we find out that answer, we add 4 to it. Okay? So let's look at our graph. We're crossing our x-axis. We're crossing our y-axis at 5. Okay? And then we're getting very, very close to the value of y of 4. If you look at your table, it's 4.0000 on and on and on. It goes very, 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 very close to 4, and eventually your calculator will give up and just call it 4, or it'll say error, one of the two. Okay? So we're getting very close to this line called 4. If we're getting very close to it, that is going to be our asymptote. So what is our asymptote in this scenario? It is where y is equal to 4. It is this line right there. Y is equal to 4. Okay? That is our asymptote. It's the line that we're approaching, but never touching. It's a horizontal line, so it's y equals 4. Okay? So that is the information we need to gather from that one. Also notice, is it exponential growth or is it exponential decay? Well, are we increasing while x is increasing? When x moves from the left to the right, is y increasing or is y decreasing? Well, when we move from the left to the right, our y is increasing. So when both x is increasing and y is increasing, that's called exponential growth. All right? Okay. I think we covered everything in that one. Now let's look at the next one. I'm going to go ahead and hit pause and set it up. All right, for number 3, we see that our equation is 1/4 to the power of x. We're experiencing exponential decay here for the first time. So exponential decay is when x is increasing, when x is moving to the right, y is now decreasing. Do you see that? So while x marches on to the right, y is getting smaller and smaller and smaller and smaller and smaller and smaller. But notice that it's approaching where y is equal to 0, but it never touches it. Now think about the last equation. If you need to rewind or scroll back or whatever, I don't know, I'm an old person. So rewind the video and look at the last equation and look at what our asymptote was. What did we add on to the back here, right? So this equation doesn't have anything added onto the back, and notice where the asymptote is. Notice where the line is that we approach but never touch. That line is y is equal to 0. We get really close to that line, but we're never going to touch it, okay? That's our table again. Notice that it's decreasing as we increase our x values. X goes from -2 to -1 to 0 to 1 and 2, and the numbers just get smaller and smaller and smaller and smaller, microscopically small, okay? Now, with 4, 5, and 6, go ahead and type those into your calculator and y equals and look at the graph. Also make a table, please, using -2, -1, 0, 1, and 2 for our x value. But if you notice, each one of them will do something different, right? When on number 4, when our b is a fraction, we experience exponential decay. But when our a is something greater than 1, we get a stretch, okay? So we're going to experience exponential decay, but it's also going to be stretched. Notice what's added to the back, nothing. So guess where our asymptote is? Y equals nothing, or y equals 0. Okay, look at number 5. Number 5 is experiencing all sorts of stuff. It says exponential growth with what is inside of here, but it's experiencing a negative a value. So we get, and that a value is less than 1, meaning it's a fraction. So it gets stretched sideways. It's all elongated. And then it experiences a negative value, which means it gets reflected across the x-axis. So that negative controls the reflection across the x-axis. So now when it says exponential growth, it's really exponential decay. This says exponential growth because it's greater than 1, but it's a negative exponential growth, which means it's a negative, right? So it gets flipped. It now turns negative. Also notice what is subtracted from the back, -1. That's our asymptote. it is going to approach -1 but never touch it. If you look at number 6, a lot of stuff is going on. We have exponential decay, but it's negative, so that's a double negative, which means really exponential growth. And then our C value back here is +2, which means we're going to get really close to +2 on our where y is equal to 2, but never touch it. Okay, explore those things, make those tables. Look at your x-intercepts, look at your y-intercepts. Notice most won't have an x-intercept. Sometimes they will. Wink, wink, hint, hint. Okay, so when it's negative, but has a positive asymptote, it will have an x-intercept. Or if it's positive and we have a negative asymptote, right? So if we had a negative asymptote on number 4 of like if we had a exponential decay with a positive asymptote, we'd have an x-intercept as well. Okay, so check all those things out. In summary, a plus c is going to give us our y-intercept. So if you take the numbers a and c and add them together, that'll give us our y-intercept. B determines if it's growth or decay. If b is greater than 1, it is growth. If b is less than 1, it is decay. And then finally, c is the asymptote. Okay, that plus or minus a number at the very end is the line when y equals that number, is the line whenever we get close to that letter, or whenever we get close to that point but never touch it. Okay, so if we had +4, we'd have y equals 4 as an asymptote. If it said -2 at the very end, we'd have y equals -2 as an asymptote. I'm going to go through the worksheet problems next on my little document camera here. If you have any questions, make sure you're posting your questions in the comment section. Please watch the videos. These are all new lessons, so watch them in their entirety and walk through them together. All right. Have a great and wonderful day.